Which is the more effective training split for maximum muscle growth and strength development? This is what the first new study I'm going to discuss today investigated. The researchers took a group of strength-trained individuals, all male, and divided them into two groups. Group 1 did basically push-pull legs, or specifically in this case, they only looked at the upper body, so they did push workouts and pull workouts. And then the other group, they took the isolation exercises from the push and the pull days and moved them to the other day. So it wasn't quite upper body days entirely, but they were basically upper body days. This split didn't really have a name, it was just an abomination, and I know that a lot of you struggle with these kind of training splits, so let's see if that struggle is evidence-based. After 8 weeks, there were no significant differences for the biceps, the triceps, or the pecs in muscle growth, nor did strength gains in 1 repetition maximum for the bench press and the lat pull down differ between the groups. Essentially, the upper-upper split and the push-pull split were equally effective. There was, however, a huge caveat. Total training tonnage, defined as weight times reps times sets, didn't significantly differ between the groups either. This makes no sense for serious lifters. If I take some of your biceps isolation exercises from your pull day, after which you already did some pulling exercises so your biceps are fatigued, and move those biceps exercises to the push day, in which you only did bench presses and pec work, so your biceps are not fatigued, logically you should do more repetitions, or you should be able to lift more weight for the same number of repetitions for those biceps exercises. The same goes for the triceps. If you move it to a pull day, the triceps is not yet as fatigued, and therefore it should be stronger. In this case, that didn't manifest in the training data, which to me renders the findings very questionable, because for serious lifters you should experience an increase in training tonnage, and that increase in training tonnage is the main reason that we see in some other research that we do see superior gains. This is basically what we see in research where they redistribute some of the training volume, where they increase training frequencies, or where they increase rest intervals. In all of these cases, we see that the main benefit of spreading the volume out more across the week or across different days or across the same session is that you increase rest times and therefore you increase total training tonnage. And that increase in training tonnage basically makes you accumulate more mechanical tension on the muscles, and that is what makes you gain more muscle mass. The training split itself is largely irrelevant. Muscle is just a slab of meat. It experiences tension and it grows. The total amount of tension, kind of the area under the curve of the tension, is the primary stimulus for muscle growth. And it's not so important when exactly this tension is experienced. And your body doesn't care whether you have a training split with a fancy name, or it makes sense, or it's like neat on paper. It doesn't matter. Muscle just experiences tension, and that's what it responds to in terms of adapting and causing muscle growth. And we indeed have a different study in which they specifically looked at taking some of that arm training volume from 1 day and moving it to 3 separate days, so spreading it out more across the week, and then either equating the volume or not equating the volume. And when equating the volume, there was indeed no difference in muscle growth, but there was a trend towards more muscle growth when spreading the volume out across the week more, and not equating the volume. So in that sense, they spread the volume out more across the week, and then they did a higher total training volume, as in more repetitions with the same weight, because they were less fatigued when they did the arm exercises on 3 different days instead of on 1 day. What we can conclude from the totality of evidence is that your training split and training frequency are not nearly as important as the total training volume. However, in terms of what the best training split is, I would favor the one that distributes your volume most equally across the week to maximize the volume per set. In that sense, the answer to the question of whether push-pull legs or upper-lower is more effective, the answer is neither is best. Full body workouts are probably most efficient overall. For a full guide on optimal training program design on maximum muscle growth and strength development, check out my online course. The link is in the description. Study number 2. What is the best exercise to get dem thighs? To answer this question, the researchers had a group of untrained women perform either Smith machine squats or leg extensions. Just like in the previous study, all aspects of the program otherwise in terms of training the intensity, how hard they trained, etc. were all equated to isolate the effect of just this one variable, exercise selection, on muscle growth. After 8 weeks, the rectus femoris of the quads, the middle quads if you will, grew more from the leg extensions than from the squats. During squats, the biarticulate rectus femoris muscle cannot effectively contribute force because it would pull you into hip flexion and essentially pulling you back down into the squat, even though its role during leg extension would be beneficial. As a result, multiple studies have shown that leg extensions are a better exercise for the rectus femoris than squats. Much more surprising was that the squats resulted in more growth in the quadriceps in the sweep, the vastus lateralis. This same pattern was observed in a previous study on leg presses, and the growth in both studies was somewhat concentrated near the knee, although the finding on that was not particularly strong statistically speaking. The reason for this is biomechanically less clear than that for the rectus femoris, but it's possible that during squats, because the quads are trained at a longer muscle length, there is more growth in the vastae than the rectus femoris. Regardless of why, it's clear that squats and leg extensions are very complementary. They train somewhat different heads of the quads, and they also have very different biomechanics, so it makes sense to do both in an optimized training program. In terms of strength development, the study had another interesting finding. Squats were more effective than leg extensions to build leg extension strength. This finding was also observed in a previous study on leg presses. However, both of these studies were in untrained individuals. It's possible that in untrained individuals, the overall benefits for strength development of doing a compound exercise, which is better coordination and letting the brain and the motor cortex teach it how to control your movements better, is more effective than the specificity principle, because in trained lifters, the specificity principle usually holds. The best way to get better at any exercise or any skill in general is to perform that exact movement or that exact skill. So in a trained individual, I have a very hard time seeing how anything could make you better at leg extensions than leg extensions. And certainly for squats, the best thing you can do is squats. Most lay individuals dramatically underestimate the specificity principle, and they think that strength is more of a trait because that's how we talk about it. Our language talks about strength as if it's a trait rather than a skill, but strength is actually extremely movement specific, especially when you get to higher levels of strength expression. However, based on this study, it seems that in untrained individuals, just the raw strength of doing compound exercises and letting the brain learn how to coordinate movements is actually more important even than the specificity principle. For a complete guide on optimal exercise selection based on the latest science, check out my online course. The link is in the description. Study numero 3 looked at the advantage of high-protein diets for fat loss, specifically looking at the thermic effect of food. Whenever you eat anything, your metabolism increases. This is called diet-induced thermogenesis, or the thermic effect of food. Basically, it takes some energy to absorb and digest nutrients that you just ate. Protein has a particularly high thermic effect of food, so high-protein diets are commonly recommended for fat loss. There are multiple good reasons to support this. However, once you're at an optimal protein intake for muscle growth, further increasing your protein intake just for the thermic effect of food is probably not that beneficial based on these results, because the researchers found that the overall thermic effect of protein was not that impressive. The researchers analyzed 28 studies and found that in short-term studies looking at single meals, high-protein meals indeed had a higher thermic effect of food than low-protein meals. However, in long-term studies, there was no longer a significant advantage. There was still an advantage, interestingly, in resting and total daily expenditure in favor of higher protein diets. How can this be? If high-protein diets no longer have a thermic advantage, how can they still elevate total energy expenditure? The reason for this is that much of the benefit of thermogenesis of high-protein diets is likely related to the increase in muscle protein synthesis. See, when you consume protein, the body preferentially uses this for muscle protein synthesis. This is why consuming protein is beneficial for strength development and muscle hypertrophy. You consume more protein, the protein gets into your muscles, you get bigger muscles, and it's that higher fat-free mass also that gives you a sustained advantage in terms of total daily energy expenditure. However, this is a very small effect. In fact, when specifically looking at studies over a month in duration, the effect was no longer statistically significant at all, meaning there was no longer any thermic advantage of high-protein diets versus lower-protein diets. So basically what is happening here, and what I think the reason is that high-protein diets are overrated for their thermic advantage, is that in short-term studies, we see a relatively substantial and impressive increase in thermogenesis. However, much of this is related to the increase in muscle protein synthesis that people get when they go from an inadequate protein intake to a better protein intake. For serious lifters, which is probably the majority of people watching this, when you're already on an optimized protein intake and you further increase your protein intake, that no longer results in a significant increase in muscle protein synthesis. Most of that extra protein will simply be oxidized as energy. There is still a little bit of a thermic advantage there, but it's very marginal, especially when you compare it to a high fiber source from a whole food like lentils or vegetables. So in practice, when your protein intake is already optimized, you're not getting much of a thermic advantage from further increasing your protein intake. And it makes no sense to eat a whole lot more chicken breast, for example, just to get that thermic advantage, because then you're consuming hundreds of calories potentially worth of energy on protein just to get a 50 calorie advantage in terms of how much extra you can eat. And it never makes sense to just eat more because there's no such thing as free energy. In the highest, best case scenarios, the thermic advantage of protein, or the total thermic effect in fact, is only 25% or so. So you're still getting at least 75% of the energy that you consume on top that will be used as energy or stored as fat even in some scenarios. Bottom line, if you're a serious lifter with an optimized protein intake for muscle hypertrophy and strength development, further increasing your protein intake because of the thermic advantage doesn't make a lot of sense. It's a really small effect. You're spending a lot of calories and possibly consuming foods that you prefer less just to get a 50 calorie or so advantage in terms of how much extra energy you can eat. That's more of a nice bonus if you happen to like high protein foods, but it's not a reason to change your diet fundamentally. For a complete review on optimal nutrition for body recomposition, check out my online course. The link is in the description. And if you like this free, evidence-based fitness content, I'd be honored if you like and subscribe.